Alright, today we're going to start on another kind of equilibrium question, which is this shelf here, and it's attached to a wall. This here is the hinge, and the shelf has got a weight force that acts straight down through its center, which will be here. So through its center of mass, that one there, so we've got force, weight. This here is a rope that's fixed from that point, and it works up this way, and that there has got a force which we'll call force tension. It's on an angle of 37 degrees, and we're going to go back to just as we did in projectile motion and in the other forces questions last week. This tension force has got a vertical and a horizontal component. We're interested in the vertical component only on this particular question. So the vertical component would be acting up there, and the horizontal one is going to be coming along this way, but that's not going to be creating a turning force. This here is our pivot, and we've got this one trying to do a clockwise turn, but we've got the vertical component of the tension force trying to do an anti-clockwise turn, and that means that the shelf neither turns that way nor goes that way. It just sits dead still in equilibrium. Now, to start this one, we're going to do just as we've done in the past. Tension, which we'll make that one the anti-clockwise, is going to be equal to tension force clockwise. And then we expand out. Torque is equal to force times distance. So we put in a force times the distance and a force times the distance. Okay, so I've added some extra data. So you can see that this distance from here to here is 9 meters. So we put in force, and this one here, we'll label it as force tension V for vertical component. So force tension vertical, which is what's making it try and turn anti-clockwise, times 9 is equal to, and now we've got force weight. So I've told you that the mass of this plank is 35 kg. So for this side, we're going to have to use force is equal to mg. So we put in a mg, our mass is 35, times 9.81, times our distance. And the plank is 16 meters long, so the center of mass acts at 8 meters from this end. So we put an 8 in there. Alright. So this side here that's the answer for that side, and that's what force tension vertical times 9 is equal to that. To get the 9 from this side, we're going to divide both sides by 9. Gets to cancel on that side, gets to be divided there, and then we end up with force tension vertical equaling 305.2. Now we need to go and draw ourselves a vector triangle. So we know that this vertical component is 305. We know that our tension force, which will slide over to here. So that one there is force tension. That is force tension vertical. This one's force tension horizontal, but we don't need to know about that one for this question. This angle you can see is 37 degrees. So you can see force tension horizontal plus force tension vertical is giving us our overall tension force. So now we've got to use our trigonometry to find out the length of force tension. So katoa, and you can see that we're working with the opposite and the hypotenuse. So we go for tan. So tan angle 37 is equal to opposite over adjacent, which is equal to 305.2. Oh no, that's not tan because it's opposite and hypotenuse, so it's got to be sine. So sine angle 37 is equal to opposite over hypotenuse, which is 305.2 divided by force tension. Now, force tension is going to be equal to 305.2 divided by sine angle 37. And that gives us an answer of 507.1, which will round off to be 510, and that's newtons to SF. And that makes sense because it's much longer on our diagram. It's got a much larger number. That length there is 507. This length here is shorter and it's only 305. So there you go.